To be able to function, the digestive tract has its own nervous system, the enteric nervous system. The system is composed of two main plexuses. On one hand, the mesenteric plexus, lying between the longitudinal and circular muscle layer. It consists mostly of a linear chain of interconnecting neurons, and because of its position, its role is to control muscle activity. When stimulated, it increases tonic contractions, increases the intensity of the rhythmical contractions, and increases movement of the peristaltic waves. On the other hand, we have Meissner's plexus, which lies in the submucosa. It's mainly concerned with controlling functions within the inner wall of each minute segment of the intestine. When stimulated, it helps control the local secretion and local absorption, because it's directly connected to the epithelium. Although the enteric system can work perfectly on its own, there is a need for the parasympathetic and the sympathetic fibers to connect both plexuses. It will greatly enhance or inhibit gastrointestinal functions. Also, connected to the enteric system, we see sensory nerve endings that originate in the epithelium of the gastrointestinal wall. They send afferent fibers to both plexuses, as well as the prevertebral sympathetic ganglia and to the brainstem. Now, we are going to talk about the movements that occur in the gastrointestinal tract. There are two types of movements: propulsive movements, or peristaltic, and mixing movements. Let's assume that this is the gut, and at some point we have a lot of food gathered, because there is no peristaltic movement. So the intestine gets distended. This affects the muscle and the mesenteric system, thus sending a signal 2 to 3 centimeters behind to start a contraction. The basic principle of the peristaltic movement is that after the contraction ring appears, everything is pushed forward. Mixing movements of the gut are different in different areas. For example, when a peristaltic wave is blocked by a sphincter, the contents mix, because the food can't go forward, so it swirls. At other times, local intermittent constrictive contractions occur. They last from 5 to 30 seconds, thus chopping the contents at different points in the gastrointestinal tract. Blood flow is related to the level of activity in a specific region. If we haven't eaten, there will be little blood flow in our digestive tract. But if we add food, a lot of food, we will need our digestive system to start working. So the blood flow will increase. The release of some hormones may increase the blood flow, but that's nothing compared to what some digestive glands do by releasing bradykinin and other kinins. They increase blood flow through the roof. It is important to know that the parasympathetic system does not directly affect the blood circulation. It acts on the digestive glands. The sympathetic stimulation has a different effect on the blood vessels. It causes insane vasoconstriction. It could stop the blood flow. But not to worry. After a few minutes, blood flow returns to normal because the autoregulatory escape. It's an ischemia override by the local mechanisms, returning the blood flow to normal. A major value of the sympathetic vasoconstriction is that in cases where other tissues need blood urgently, the digestive system can provide as much as 200 to 400 milliliters of blood. Thank you for watching. Please like, comment, and subscribe for more videos.